Hello, everybody. So in this video, we're going to start the discussion on some of the important notes that we have to keep in mind while doing the mass balance calculations. And in this, and this is this and then the coming one or two videos are going to be the basis on which we will put all the basics of the systematic approach we will follow to do the mass balance calculations. The previous example that we solved was a little يعني randomly calculated or solved. We tried different things. We were just kind of shooting in the dark without having an idea if we are going to get something from this equation or not. So this is going to be more systematic from now on. Type for the first point that I want to make here, it's a very mathematical point. This mathematical point is regarding the dealing with algebraic equations. So I have here a set of three algebraic equations in three variables x, y, and z. And there is something that is very well known that we can do with the equations, which is um, dealing with equations in an algebraic way, meaning that I can do mathematical operations to the equations by adding multiplying an equation by a factor and adding it to another equation. So we have a new equation of a, b, and c. We can subtract two equations. We can add the three equations. There are many options that you can do regarding the way you deal with these equations. You can produce hundreds of equations given these three equations. And the point that is important to be kept in mind is that having all these equations written, whether you produce 3, 5, 10, 100,000 equations, all these new equations are dependent equations. And since they are dependent, it means that from a very pure mathematical point of view, they're not adding anything new to our knowledge about the relations between x, y, and z. So they are still three equations. Mathematically, they are still three equations. So if you try to solve these three equations, and these three equations, they're going to give you the same answer. They're not new equations. The values of x, y, and z that you're getting from here are the same as the values of x, y, and z you're getting from here. So this is a very important thing to notice, is that the dependent equations are not adding new information to us. They are just another way of writing the equations. This is how we look at the dependent equations. So this is a very important thing. The reason we are discussing this mathematical point here is that um, um, we will see this in this example. So we have a separator that has a one feed stream that's called N1. It contains three components, A, B, and C, and it produces three streams, N2, N3, and N4, and each one of them contains three components, A, B, and C. And I put YA, YB, and YC is I don't know any of them, so I put 1C as 1 minus YA minus 1B because the sum of these three is 1. So C is, or the mole fraction of C is 1 minus the sum of the rest of the mole fractions. So this is the problem that we have. And now we want to write the equations, the mass balance equations, to describe this unit. So the mass balance equations that we can use are, we have four options, A, B, C, and the total. So if you write the mass balance equation of A, it's going to be the A in stream 1, so it's N1 YA1 equals N2 YA2 plus N3 YA3 plus N4 YA4. Very straightforward. The same for B. It's instead of A, it's going to be. For C, it's the same, but instead of YC, it's 1 minus YA minus YB. So this is N1 YC1, which is 1 minus YA1 minus YB1, and the same for N2, N3, and N4. And for the total, it's going to be N1 equals, the total feed is N1 equals N2 plus N3 plus N4. So these are the equations that we have. If we keep in mind what we mentioned in the previous slide about the dependent equations, and we look at the equations that we have here, we will notice a very interesting thing, that the fourth equation, which is equation 4, is equal to the summation of the first three equations. Let's take the first term, for example, the left-hand side. So we have here n1 ya1, n1 yb1, n1 multiplied by 1 minus ya1 minus yb1. So if we add these three terms together, it's going to be n1 ya1 plus n1 yb1 plus n1 minus n1 ya1, which is this, minus n1 yb1, which is this. So it's going to be n1. The same for adding these three terms. This will produce n2. These three terms will produce n3. These three terms will produce n4. So equation 4 is the summation of equations 1, 2, and 3. So it is a dependent equation. And since it's a dependent equation, so the four equations that we see here are actually three independent equations. They are three independent equations and one dependent equation. So uh, the 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 equations that we can use to do the mass balance calculations are not four, they are only three. You have the freedom to pick any three of them. I can use 1, 2, and 4. I can use 1, 3, and 4, 1, 2, and 3, 2, 3, and 4, 1, 3, and 4. It's totally fine. As long as you are picking only three out of the four, because you know the fourth one is going to be dependent on them. So um, the rule of thumb is that the number of equations or independent equations that describe a unit is equal to the number of components. Here we had three components, so we had three equations. If you have five components, you have five independent equations. If you have two components, we have two independent equations, and so on. So this is a point that must be very, very clear, that the number of independent equations equals to the number of components. So this is a very, very important thing, because you have to know beforehand how many independent equations you have, so you know beforehand if the equations would be enough or you need to do something else. And we will see this in more details later, inshallah. So this is a very, very important thing. I hope it's clear, and we will continue the notes on the mass balance next time, inshallah. See you there.